everyone, we're going to find stationary and inflection points by taking first and second derivatives of this polynomial. Then we're going to graph it on the interval. And before we get started, I'd like to point out that this is a polynomial with degree 3. That means, and it's positive, that means that it resembles a cubic function like this. That means our end behavior is like this. We're starting in quadrant 3-ish, depending on where we start, but we're starting in quadrant 3 and ending in quadrant 1. So your graph should resemble that. Now, it might be something more like this, but your end behavior will be the same right in here. So that tells you something there. Also, because our degree is 3, we have at most n minus 1 turning points. So our n is 3, so that means we have 3 minus 1 turning points at most. We might have less. So we have at most 2 turning points. That helps, just knowing that. That's mainly from pre-cal. So let's continue on, and we're going to take derivatives. And what we want to try to find here, I have a little diagram here of what this looks like. Now, I picked this diagram because it resembles what we're going to be drawing. There's our end behavior here, and an inflection point would be here. That means the slope goes positive to positive, but at these points here, our minimum, our stationary points, our gradient is 0. So this is 0, and this is gradient is 0. All right? So basically what we're going to do is take the first derivative. And remember, the first derivative equals the gradient. That means how does the points change? How your points change. Well, the first thing we have to do is find the y-intercept. So let's write down the equation again. So we have f of x equals x cubed minus 9x squared plus 24x minus 9. So our y-intercept is just going to be, there should have been an x here, x minus 9. So when you plug in 0 here, all these x's go away. So you're going to have f of 0 equals 0 minus 0 plus 0 minus 9. So our y-intercept is 0, negative 9. So there's that point right there. And remember, we're supposed to graph from 0 to 5, on the interval from 0 to 5. All right, so let's take our first derivative of this. F prime of x equals 3x squared minus 18x plus 24. Now, to find your stationary points and the coordinates of the stationary points, we are going to set this to 0 because we want our gradient to be 0 to get the max and the min. So we set this to 0. I'm going to factor out of 3. And I continue factoring. It's x minus 4, x minus 2. So basically we have a min or a max at x equals 4 and x equals 2. So we have it right in here and here. To get our y value, you plug it back in to your original equation. So we have f of, let's do 2 equals 2 cubed minus 9 times 2 squared plus 24 times 2 minus 9. and that's going to give you -9. Whoops. That's going to give you, at 2, it's going to give you 11. So at 2, we're going all the way up to 11 here. All right? And then let's try our x as 4. So you just plug in the 4 and you get 4 cubed minus 9 times 4 squared plus 24 times 4 minus 9. And that's going to give you 7. So we have 4 comma 7. And this one right here was 2 comma 11. So let's do 4 comma 7, which is right here. Now, based off the knowledge that we only have 2 turning points, your graph is going to be starting here. Let me do black or green. So your graph's going to go something like this. So this is going to be your maximum up here. It's going to come back down here and probably go back up here, because you have to have 2 turning points. So this one would be your local max stationary point. The gradient is 0 here. And this one would be your local minimum. Now we have to see if we have any inflection points. So basically what we want to know is if we have any, for example, if we have anything in here. So you can concave down a little bit, and if it does something like that. Inflection point would be where the slope is negative here, and also the slope is negative here. Or we could have one up in this area. So to do that, we take the second derivative. So we're going to take the second derivative. And our first one was, first derivative was 3x squared minus 18x plus 24. So therefore, our second derivative, f double prime, is going to be 6x minus 18. Now, I'm going to go ahead and plot these points again. 2 went to 11, and 4 went to 7. So I'll put the 7 here. This is not drawn to scale. I couldn't get all the big numbers on here. So we already kind of have something like this. So basically, we're going to set this to 0 to see if we have any stationary points. Factor out of 6. We have x minus 3. So x equals 3. So, and don't forget, your second derivative is how the gradient changes. That's going to give you your inflection point. So at 3, we want to know what's going on at 3, where it equals 0 here for the slope. So we're going to plug it back into our original equation. We're going to have f of 3 equals 3 cubed minus 9 times 3 squared plus 24 times 3 minus 9. And that's going to equal 9. So basically we have at 3, we're at 9. So that's an inflection point right here. So our graph looks like this. We don't know what's going on at 1. So let's see what's going on at 1. So if we have f of 1, we have 3 to the first power minus 9 times 1 squared plus 24 times 1. It's just 24 minus 9. So that's going to be 3 minus 9 plus 24 minus 9. So that's going to be 27 minus 18. And that's going to equal 9. So at 1, it goes to 9. So you can graph it here, kind of graph up to here. It comes back down to here. We have an inflection point here. It comes back down here. And then I already put in 5 as well. So if you plug in 5, you're going to get 5 cubed minus 9 times 5 squared plus 24 times 5 minus 9. And that's going to give you 11, I believe. So that equals 11. So we're back up to 11 here on the 5. So there's your turning point here. All right? So let's look at this again. This is a positive slope here. At this local maximum, it's 0 gradient. This is a negative gradient. We have an inflection point here, negative gradient here. Then we have a turning point here, and this is a positive gradient here. And then we graphed it like that, and it does match our what we want it to do with our graph here. Now, the next thing you kind of want to do is, let's see, what we want to do is plug in our points 2 that we got for our stationary points into our second derivative. So when you plug in the points in your second derivative, I'm going to do it right here. You get 6 times 2 minus 18, and that's going to equal negative 6. And then plug in your 4. That's going to be 6 times 4 minus 18 equals 6. Now, what you need to know about that's going to give you your turning points. So, if you have a negative 6, people think that's a minimum, but no, that's a maximum. Because that means the turning point is turning negative. So, at 2, it's turning negative here. It's going negative. All right? So that's where at your maximum. If it's a positive number, that is your minimum. All right? So just remember, these are kind of, students get confused. They think it's minimum because it's negative. If it's negative, it means it's a maximum. If it's positive, it means it's a minimum. Okay, that's it. Thank you. Have a nice day. Bye-bye.